Okay, so I wanted to show you a kind of tricky one that is possible to show up on the AP test. And so they would be looking for this on an open-ended question perhaps, and they would want to see the algebra that you use in order to solve it. So the first note I want to make is that I'm going to use a property of limits saying that if I have the limit as x approaches anything of a function over another function, that I can look at them in two parts. I can find the limit of the top, I can find the limit of the bottom, and then I can take my answers and I can make a fraction out of my answers. Okay, so that's a property of limits that you learned way back in chapter 1. And so I'm going to be using that mainly. The other thing that I'm going to be doing is a slight algebra trick, because I want to be able to evaluate this limit quite easily. So I'm going to multiply by a creative number 1. And basically, I'm going to multiply the numerator by 1 over the square root of x squared. The reason I chose that is because I'm matching this piece of that term right there. Okay? And then as long as I do the same thing to the denominator, then that's a creative number 1. I also want to point out that technically, although I didn't write it, I'll write it now. The square root of 1 is the square root of 1. So, and that's 1. So remember, the reason I'm using the square roots is because I need to be able to multiply inside that radical on the denominator, and therefore I have to have a matching radical in order to do that. So on the top, I'm going to look at it separate, and it's basically x over square root x squared. Okay, so in other words, it's basically x over x, which means that limit is now going to be 1, because I'm looking at the limit as x goes to negative infinity, and that simplified down to a constant. And so the limit of a constant is a constant. Okay? And then we're going to come back to this at the very end, because it makes a difference whether you're heading to negative infinity or whether you're heading to positive infinity. So just kind of put a note there. I'm going to come back and talk about that in a minute. Now, looking at the denominator, I want the limit as x goes to negative infinity of the square root of x squared over x squared, because as the radicals come in, they're all under one radical. And then I have 1 over x squared. Now, if I look at these terms individually, that's technically the limit of the square root of 1 plus the limit of 1 over x squared. So as I look at this limit, and I start using my limit rules, remember, the limit of a constant is a constant. And then when you have a constant on top of a variable with an exponent, remember that limit rule is 0, or you can use the n equals 0, m equals 2 rule, because this is x to the 0 on the top, right? And so again, that's going to be 0. So in the denominator, this answer is 1 as well. So it might look like my answer is 1 over 1. However, we need to remember that we're heading to negative infinity. We're taking the limit as x goes to negative infinity. So back in the original problem, at the very beginning, we know that that value would be a negative number over a positive number, because that square root is already positive. It's telling you that that's positive square root x squared plus 1. And so when I look at that and I say, okay, that's going to be a negative over a positive square root, then when I look at that as 1 over 1, my final answer is that that is -1. And so that negative came about logically. I didn't actually plug in negative values. I was just looking at it, saying which side am I looking on, negative infinity or positive infinity. If you have any questions, please bring this up in class. Thank you.